So let's start with this one. So for this one, you just want to look through each one and see what's true before you look at the choices. So this one says limit as x goes to 2 from the left if f of x exists. So 2 from the left would be this thing here. Whatever it's approaching, this y value. This y value exists. So this is true. 2 from the right means it's this thing here. It's approaching this y value. This y value also exists. So this is true. Now the problem is here is when it says limit as x goes to 2 exists. For this to be true, these two have to match. So now if we look back at here, these two are different y values. So therefore the limit does not exist. So because it's D and E, this is not true. So it's just 1 and 2. So it's C. Alright, let's look at the next one. Alright, this one is a simple limit question, so we can just rewrite this, factor this. The goal of factoring is to cancel out terms like this, and then we're just left with limit as x goes to 1 of 1 over x plus 1. You just plug in 1 into here because it works. And just remember, whenever you have the opportunity to directly plug it in and it gives you a value, go with that. The reason we can't just plug in from the first step is because you'll get 0 over 0 if you plug in 1 at the first step. So the limit is 1/2. Now let's look at this one. So for this one, it's always helpful to separate this fraction like this. And doing this, you just get limit as x goes to 0 of 1 plus sine x over x. And you should be familiar with this sine x over x thing by now, as x goes to 0. This is just 1, so you just have 1 plus 1, so it's 2 is your answer. And the next one. So for this one, you want to make use of that same identity for sine x over x. You can make use of this identity by just rewriting this as and this is because tan x is sine x over cos x, and then you have the times 1 over x. That's just how I like to rewrite these. Whenever I see a denominator, I just do times 1 over x. And then now we can reorder this a little bit. Our goal is to get the sine x over x, so we can reorder it like this. And when we reorder it like this, we see that this here is 1 from the identity. This one, you get 1 over cos 0. And then cosine of 0 is just 1. So this is 1. And then for this one is another conjugate question. So you just multiply it by the conjugate. Whenever you see it like this, it's usually conjugate. And again, if you were to try plugging in 0 on the first step, you'd get 0 over 0, or something similar. So if we try multiplying this by the conjugate, And the point of even multiplying by the conjugate, the reason we do this is because we're making use of this a squared minus b squared is equal to a plus b times a minus b. You just make use of this to rewrite it for us. So it becomes this squared. So square root squared, it cancels out. So you just have 2x plus 1 and then minus your b squared. So 1 squared is just 1. So then you're left with this. And then you can simplify this a little bit. I'll just simplify it on this step. So the 1's cancel out. You're left with this. And from here, the x's cancel out. And you're just left with 2 over square root 2x plus 1 plus 1. When you plug in 0 here, you get 2 over, let's see, 2 over 1 plus 1. Right, plug in 0. Yeah, 2 over 1 plus 1. 2 over 2, which is 1. Next one. So this one is an infinite limit question. So you can instantly get the answer and say that this is infinity by just comparing the degrees. But if you want to do it the long way, you can also do it because sometimes your teachers require that. So if you're to do it the long way, it would look like this. So you divide by the highest power, which is, in this case, 3 is the highest power of anything. So you divide by n cubed, and then n squared divided by n cubed plus 10,000. Yeah, 10,000 and divided by n cubed. And immediately looking at this thing, you know that this goes to 0 because if you were to simplify this, it's 10,000 over n squared, and then as you increase n to a huge number, that thing's going to approach 0. So this thing is approaching 0 as n goes to infinity. So it just simplifies down to uh, 4 on the numerator over 0. And the reason we say that this is infinity is because in this context we can just compare the degrees and see that as we are approaching a positive infinity, we must be approaching a positive infinity because our numerator is going faster, so we're approaching infinity. This one's another infinite limit question, as you can see here. So you can just compare these coefficients. So you just see this right here, and then you know the answer is already 2 over 5, just comparing those coefficients for the highest power, which is 2. You can solve it the long way as well and try that, and then you'll get 2x squared. You're dividing by the highest power, which is x squared. Divide everything by x squared because 2 is your highest power. Yeah, and then divide by x squared for everything. Let's try that. And then limit as x goes to infinity of this thing is 0. For this thing is 0. Just get used to the fact that when you see 3 over x squared or something of that similar form of 1 over x, it's going to go to 0 as you go to infinity. So this simplifies down to just the x squareds cancels out here. this is 0, this is 0, so you're just left with 2 over 5. And then the last one, same rule here, except that make sure you want to pay attention to this. It's an infinite limit, but you're approaching negative infinity here. But you can just use the same concept as the infinite limit. There is only some very, very special cases in which this negative infinity matters, but you only see those in Calc BC, so you don't have to worry about that much. It's just for questions where they ask you something like 4x plus 6, let's say. I'm just making this up. 4x plus 6 as x goes to negative infinity. This is equal to negative infinity, but you can just tell that by just plugging in a really, really large negative number, like negative billion or something. You get like a really large negative number. It's approaching negative infinity. So yeah, just make sure you're paying attention of what you're approaching. But you can use the same idea. Compare this. This is 1. So it's 3 over 1. So the limit is 3. But you can try uh, doing it the long way as well. So divide everything by the highest power. Highest power here is x cubed. And then divide this by, I'm just used to, from the very first step when I divide by x cubed, distributing it, because there's no point in leaving it as all of this over x cubed, because you want to separate it, so you evaluate each of these individually. And now after we divide everything by x cubed, we can notice, like I said before, this is 1 over x, this is 1 over x cubed. Both of these, as x goes to negative infinity, is also 0. You can think of it as something like this and this. This is 1 over x, right? As x goes to infinity, this thing is approaching 0. And as x goes to negative infinity, it's also approaching 0. So now let's just simplify this. And when we simplify this, we're just left with, actually, yeah, we're just left with 3 over 1. Since this is 0, this is 0, this is 0, this is 1, this is 3. So you're left with 3 over 1, so it's 3. Alright, so these are the practice questions. If you have any questions, let me know. Thanks.